we will discuss few important questions from liquid solution one by one, which are based on the CBSE board. State Henry law. Why is air diluted with helium in the tanks used by scuba diver? So first of all, we need to know this about Henry law. What is the statement? What is the exact statement we need to write? Then state Henry law. Again, the same kind of question, now related with the numerical. So first of all, we need to see what is the exact definition for Henry law. So the Henry law is the partial pressure of a gas is directly proportional. So partial pressure of a gas above liquid surface is directly proportional to mole fraction of a gas inside the liquid or inside the solution. And then if you want to write partial pressure is equals to, then we need to write a Henry constant multiplied by mole fraction. So the exact definition is this. Henry law states that the partial pressure, this term is very important, we need to write. If we are just saying pressure, then it will be wrong. Partial pressure of a gas in the vapor phase is proportional to mole fraction of gas in the liquid or inside the liquid solution. And this is the mathematical expression where KH is Henry law constant and different gas will have different KH value. So this is the exact definition that we need to write. Now the second part is the numerical. Now we will see. If you want to solve the numericals, then we need to solve it stepwise. So according to these steps, first of all, we will write the given values. Given value. Now the first given value we can see, they have given temperature, that is 298 Kelvin. Second is partial pressure, that is 760 millimeter of Hg. Then KH value they also gave. KH is equal to 1.25 into 10 to power 6 millimeter of Hg. Now we can see the pressure, unit of pressure and the unit of KH are same, means we don't need to convert. If they are different, then we need to interconvert, and then we need to convert into a single unit, in a single unit form. Now we can write the formula. The formula is partial pressure of a gas is equal to Henry law constant multiplied by mole fraction. So pressure we already have, KH we already have, but we don't have mole fraction, how much gas is dissolved in terms of mole fraction. That is called solubility. This is what we need to find. So mole fraction will be equal to partial pressure of a gas divided by KH value. So partial pressure already is given in the millimeter of Hg, so we can directly write 760 millimeter of Hg divided by 1.25 into 10 to power 6. Now we can solve this directly and we will get this 760 divided by 1.25 into, it will become 10 to power minus 6. Now we can just divide this value and we will get our answer. So 760 divided by 1.25, 608 into 10 to power minus 6, or we can write 6.08 into 10 to power minus 4. This is the correct answer we have. Now we can move to the second question, and this is again one of the most asked. These kind of questions they will ask multiple times. The second question is, calculate the boiling point of solution when 4 gram of MgSO4 was dissolved in 100 gram of water, assuming MgSO4 undergoes complete ionization. Now first of all, we need to write given values. What are the values we have? First of all, weight of MgSO4, which is 4 gram. Along with weight, we can write molar mass of MgSO4, which is 120. Then we can write dissolve in 100 gram of water. So we can write mass or weight of water, which is 100 gram, and Kb is also there. Molar elevation constant, that is 0.52 Kelvin kg per mole, and this is also in gram per mole. Now these are all the given values and we need to find the boiling point, and they are saying assume complete ionization. Now complete ionization means if you have MgSO4, it will dissolve completely in Mg2 positive plus SO4 2 minus. Now, if it is going to dissolve completely, let's suppose if you have 1 mole of MgSO4, it will be 0, it will be 0. After dissolving, it will become 0, it will become 1, and it will become 1. Means the value of I, want of factor, will be 2 upon 1, which is equal to 2, which is called number of particles after dissociation upon before dissociation. So I value is 2. This is what we need to find. If we got the I value, now we can solve this. Now we can apply the formula of delta TB, elevation in boiling point, which is equal to I multiplied by KB multiplied by molality. So delta TB will be I, which is 2, multiplied by KB, which is already given in the question, 0.25 into molality. So molality is given mass of solute 4 gram divided by molar mass, which is 120, divided by mass of solvent. So mass of solvent is 100, but in kg. So again multiplied by 1000 here, because 100 divided by 1000. Now we just need to solve these values. 2 0 will cancel out by these 2 0, this 0 will cancel out by this, and the final equation that we are getting is 2 multiplied by, again 2, it will become 6, 4, it will become 2, it will become 3. So our final answer is 0.52 multiplied by 2 divided by 3. Yes, and after solving this, we will get the value which is equal to 0.34. This is the delta T. Now we need to find the boiling point. So the boiling point will be, so boiling point of water is 100, but we can see there is an elevation which is equal to 0.34. After adding, the final boiling point will be 100.34. This is the elevation in boiling point. And we can also see this is how exactly we need to solve. 100.34. Now, what is want of factor? So there are multiple definitions of want of factor. The easiest one is want of factor, which is represented as I. It represents number of particles after dissociation, or association, depends upon what is happening, divided by number of particles before dissociation or association. Or we can also write observed colligative property divided by calculated colligative property. That's also fine. It is a ratio. Now, what type of values can it have if it is forming solution of solute molecule undergoes dissociation? Dissociation means, let's suppose you have A is dissociating into B plus C. So again, number of particles after dissociation is 2 divided by 1, means the I value is greater than 1. Or maybe possible we have two particles, let's suppose A plus B, and they are combining, and after combination they are forming C. So now if I want to write I, number of particle after association is 1, before association was 2. So here this time I value is less than 1. Means what are the possible values? So I can be greater than 1 and I can be less than 1. If it is greater, means it is a case of dissociation. And if it is less than 1, means it is association. And if I is equal to 1, then neither dissociation, neither association, the substance will be non-electrolyte. So these are the two values that we can see for dissociation and for association. So here we can write directly. So for dissociation, I value will be greater than 1, and for association, I value will be less than 1. Yeah, and this is the definition for want of factor. Again, experimental or observed colligative property divided by calculated colligative property. Calculated means by applying the formula we can figure out that calculated colligative property. And another way of finding colligative property is we can go to the lab and we can perform some experiment. So that will be the observed value. Now the next question, give reason 0.1 m KCl has higher boiling point than the 1 m glucose. So now boiling point means, higher boiling point means we will write the formula for elevation in boiling point, which is equal to Kb multiplied by molality, and there is a term I. Now I will be 1 if we have non-electrolyte which is not going to dissolve in water, and I value can be greater than 1 usually for electrolytes. So if we taking KCl solution 1m, it will dissolve in K positive and Cl negative ion. So we took 0.1 m KCl, but after dissolving 1.1 will form 0.1 K and 0.1 Cl. So automatically total number of particles will be 0.2. Total molarity will be. Now if we have glucose molecule C6H12O6, again it is not going to dissociate into any ions. It is a non-electrolyte, so I value will be 1. So even though they have the same molarity, but still KCl will have higher boiling point, because elevation in boiling point for KCl will be more because it is a electrolyte. Now the second part is meat is preserved for a longer time by salting. Again we can see the exact reason. Salting is used because most bacterial and fungus are other potentially pathogenic organism cannot survive in highly salty environment due to the hypertonic nature. Because we have hypertonic solution, any living cell in such an environment will become dehydrated through osmosis and die or become temporarily deactivated. That's why we use this much. So hypertonic solution means we have a cell and we have a hypertonic solution, means where we have a highly concentrated substance, concentration of NaCl, and let's suppose any solute will be very higher, so all the water molecule will move out from the cell, it will dehydrate. That's why it is acting as NaCl can be act as a preservative, and this is the reason for the first part. So these are some of the important questions from the liquid solution for the CBSE board.